I'm Andrew Bugden, and I wanted to talk a little bit about the piece I had in the Interweavings exhibition in October through November 2019 at Center 3. First, thanks to Sally Frater and Center 3 for including me in this exhibition and putting me in good artistic company. The exhibition was about the intersection of craft and technology, and my piece took the form of a hooked rug representing a map of the celestial sphere. In making a map of the globe, map makers were faced with the challenge of representing a sphere on a flat surface such as a piece of paper. You've probably seen the various forms this has taken. The one I used was the one most familiar to me from early childhood, called the interrupted Goode homolocene projection. That's Goode with an E at the end, referring to John Paul Goode, who came up with this solution in 1923. And homolocene is a term he invented to refer to the hybrid of mathematical functions that he used to map the sphere of the globe onto a 2D surface. The interruptions are the slices that, on a map of the Earth, cut into the oceans and give this the kind of flattened orange peel shape that you see. This was done to try to minimize the distortion to the continents. All projections of a sphere onto a two-dimensional surface necessarily introduce distortions, and that's part of what I was interested in when making this piece. I was thinking about how information can be encoded into something, an object or an image, and how, despite distortions or low resolution, that information can still be extracted. I wanted to use this particular shape that's very specific to the Earth and apply it to the celestial sphere. For those who don't know, the celestial sphere is an imaginary surface, the inside surface of a sphere onto which the stars are mapped as seen from Earth. This sphere shares a center point with the Earth, as well as the equator and poles. I also included the line of the ecliptic, that's the curving blue line that crosses the equator at 2 points, those being the vernal and autumnal equinoxes. The line of the ecliptic traces the apparent path the sun takes through this backdrop of stars due to the tilt of the Earth's axis in relation to its orbit of the sun. It's roughly along this ecliptic line that all the zodiac constellations are found, and they're all represented here. In fact, all 88 constellations, as recognized by the International Astronomical Union, are depicted. I was thinking about what the smallest resolution could be for representing these, and I figured one piece of yarn per star was the simplest practical way of doing it. This, of course, introduces further distortions, as the length of yarn also means that a star can be moved several light years with the swipe of a hand, particularly at the more compressed areas near the poles. My hope is that all of the clues, the shape of the map projection, the equator and ecliptic, and the ring of our Milky Way galaxy, which is the gray and gray-brown band that runs across this map, and perhaps recognition of a constellation or two would enable people to recognize this as a picture of space in all directions as seen from the Earth. There's a further distortion in that clusters of stars as seen from Earth are often not even close to each other in space. They just appear that way in the line of sight from our planet. As far as the recognized constellations, I didn't want to draw any connecting lines or borders, since I wanted to restrict it to natural information only. In fact, the constellations as they're defined each describe an area of space with a border around it, including and named after the constellation contained in them. One of the functions of a world map is to describe the geography of the Earth, but maps are also used to draw political borders, and of course have also been used as tools of conquest, colonization, and to assert claims of ownership. But this arrangement of stars has existed since before humans were around, making it the persistent backdrop of all human activity on this planet. Deciphering pictures from these clusters of more or less random static seems to be a natural instinct of the imagination, like seeing a face in burnt toast or a cloud that looks like a horse, and it's something people throughout history have imagined and recorded using the same backdrop we see today. Saying that one interpretation is correct or universal may be useful for science, but it's essentially arbitrary when applied to distant stars that no human has come anywhere near. What is shared among all people is a life lived under the natural pattern of these lights in the sky. Which brings me to the reason I wanted to make this map in the form of a hooked rug. I've done some other rug pieces in the past that use the pixelated look of hooked yarn to imitate pixels on a computer screen and explored ways that information can be transmitted or not transmitted, and thinking about the crossover of information and imagination, so I thought it could apply to this idea. For me, the crafty and low-tech look evokes a homey coziness. I wanted to collapse the distance between the cold expanse of space and our familiar home. The inaccessibility of distant stars presented in a tangible and non-threatening form, looking both outward and inward simultaneously. I wanted to make something that was accessible, even a bit humorous, but that also contained true information, as well as being a commentary on the necessary distortions of translation. This piece seemed to me the ideal universal home sweet home wall hanging, as it's essentially the unchanging view from our collective window.